Hello, my name is Trenton Lambert, and we'll be doing the pH lab today with the red cabbage. So, with the pH in the red cabbage for strong acids and bases lab, all of our liquids around us every day are either acidic or basic. For example, our strong acids will be more sour, and then our bases will be more bitter. The strength of the pH scales is determined by the concentration of hydrogen ions, where a high concentration of hydrogen ions indicate a low pH and a high concentration of hydrogen ions indicate a high pH. The pH scale ranges from 1 to 14, where 1 to 6 is classified as acidic, 7 is our neutral, or neither a base or an acid, and 8 to 14 is classified as a basic. I have my laptop here, and I will be following the guidelines of the chart to determine if it is a strong acid or a base, depending on the color and neutrality of it. So I have my materials, which is my red cabbage boiled. I have my distilled water, tap water, soaked with maybe a tablespoon or two of water. My vinegar, my local grocer did not have ammonia, so I did find some Windex that had ammonia in it, so this is what this is. My lime juice, and then my baking soda with a little bit of water so to be able to mix. So the vinegar, I believe, will have somewhat of would be an acid. The ammonia would be an acid, lime juice an acid as well. The baking soda or baking powder will probably be around the neutral state, probably around a 7. Soap will probably be a base, as well as our distilled water. Since we live in Oklahoma, our tap water is really hard, so I would say I have a higher concentration. And my pH strips, just a moment. My local grocery did not have any of the normal test strips for water or for pH balances, so I found some Pool Care ones. And the pH only ranges from 6.4 to 8.4 on here, but I'll also pull up a pH scale on my phone so I have a better indication of the pH for each one, which is shown here. So on these pool test strips, the second little notch here will be our pH indicator. So that's the one I'll be using to base the values off of. Okay, now I'll pour in a little bit of the cabbage juice in each one, and then we will test. I'm sorry, we will not be doing that. Stick these in here just for a moment. And we'll take them all back out to dry. Okay, now that we have that done, we can go ahead and label each one with their pH value. So we'll start with the baking soda. And it's kind of like the pink color. It's the second one here on the top. And that'll be close to around a 7.8. And I'm just going to record it here on the laptop. Next one is the lime juice. So on here it's kind of a bright yellow. So it's not really indicated here on my pH values on the bottle. Hold it up next to my phone. So it looks more to be an acid, about level 3. Then my ammonia is a bright fuchsia pink color. And that should be around the 8. Let's see. Around 8.4 here on my test bottle. Then my vinegar. It's closer to a 4. We'll go with 4 for an acid. Then the soap didn't really have much of a change. It's kind of the bright yellow. That should be around a 4 as well. And then our tap water has turned it pink. And that seems to be 7.8. And then our distilled water did not have a change at all, so it's kind of a neutral. We'll bring that to a 7. Okay. Now I'm going to dump in a little bit of the cabbage juice to each one to determine the pH of the cabbage juice. Give that a mix, see if that will change color. starting back off with the baking powder. Looks to be around a 9. The lime juice, more on the pink side. So I'm going to put that at a 0. It's closer to the higher acidic side. We have our ammonia, turned it green. That should be around 7 for neutral. And the vinegar, turned it red, which would be an acid. We'll give that a 1. Then our soap is more pink, purple. We'll put that at an 11 for a base. Then our tap water, turn it this dark blue. Give that a 10 as a base. And then our distilled water is roughly around the same color as our tap water. I'll give that a 10 as well. Okay, thank you for watching.